to the world where diamonds grind and spin. Concrete cutting experts, let the show begin. From diamond blades to core bits, we got the gear. Tune in to DPU, your podcast is here. Diamond Products University, where knowledge is key. Cutting through the toughest jobs, just like 1, 2, 3. With Jim and Jimbo, and guests who know it all. Join us on this journey, we'll answer every call.
Welcome to Diamond Products University podcast. If you're listening to this, you're most likely part of the diamond tool or construction industry. Whether you're a salesperson, counter sales, cutter, contractor, or customer service, we will bring you experts in the industry that will teach you the basics and advanced info on diamond tools and equipment for the construction industry. Welcome to Diamond Products University. All right, folks. Well, welcome back. We have another of our Diamond Products University podcast. Episode 2, Jimmy.
It is.
It is.
Oh, who's that?
Hey,
That's Tom Walsh.
Tom Walsh here.
That's right. Tom Walsh has been with the company how many years?
43.
Right.
43 years.
We said 41 last time, gang. He's we got him back because kind of nobody knows more about what we're doing here than Tom. He's been with us for 43 years. Did such a great job last time. We thought we would sort of continue on the subject of Diamonds 101, more or less, right?
Yes, we're going to get into some of the factors that affect performance still. We didn't really finish that up last time. So we're going to start maybe with hard material versus soft materials. What makes up a hard material versus soft, and how does that affect cutting?
Well, the last podcast, we touched quite a bit on the aggregates, and we talked about how the different performances are affected by the aggregates themselves, the actual rock that's in the concrete. One thing that is a really good illustration of that is you have limestone, which we talked about the Mohs hardness as well last podcast, as a 4 hardness, all right? And then you look at Texas, like say down in Houston, it's a flint aggregate. That's more along an 8 or a 9 hardness. Now, if you took a blade and ran it in Ohio, typical inch feet would probably be somewhere around 50 to 60,000 inch feet in limestone. Now you take that same blade and you take it down to Houston, instead of 50 to 60,000, you're getting 4 to 5,000 inch feet. So you're talking a whole lot less yield just based on the hardness of the aggregate that's in the concrete. And needless to say, if you get 60,000 inch feet out of a blade, your inch foot cost is going to be around 1 cent to 2 cents per inch foot. We talked about that last time. Inch feet is length times depth. To find out your cost per inch foot, you take the cost of the blade divided by inch feet to get your inch foot cost. So 4 cents in limestone, it can run as high as 19 or 20 cents in hard rock. And when you're on a job that has lots of lineal feet, that can be a huge difference. So very important there.
Yeah, really. Well, you were saying too, I mean, that lends into the fact that the country's so big, the difference in aggregate from place to place really changes the difference in value or cost of a blade from place to place.
Right. And you say you're in Ohio and you're bidding a job and somebody says, well, we'd like you to bid a job over in Flint, Michigan, let's say, where they have some really, really hard rock in Flint, Michigan. And you just, all you know is limestone and you bid that job based on that. You show up to the job in Flint, you're going to get your, what handed to you.
Yeah.
So the compressive strength, how does that affect, and what is compressive strength?
Compressive strength is when you pour concrete, obviously it's in a liquefied state, and as it evaporates, it hardens. As it hardens, it strengthens. So you have to have a certain PSI for traffic, any kind of activity on the pavement. It has to be a certain PSI to be able to allow that. And you have some cases where like a sidewalk might be 2,500 to 3,000 PSI. You've got places in nuclear plants that can be 10 to 11,000 PSI, which means it's extremely compacted, strong concrete. As far as how it affects the diamond tool life, it's a very small part of it. It's something you have to figure in when it's extremely high PSI, but for the most part, it's something that we look at. Unless it's completely out of whack one way or the other, it's not that much of a factor in the cutting.
So how do they make that PSI higher? I mean,
Typically, you retard the concrete. You keep the concrete from curing. The longer you can keep that concrete from curing, the stronger it'll be, because the evaporation process slows down and it gives that concrete more time to harden. So as they want to get, and there's other additives you can put in concrete, such as calcium and a few other things, that'll bring it up to required PSI as well.
so don't they use vibrators? There's different vibrating machines that they use in those.
Yeah, and typically that's, you've got your aggregates, and they're all jumbled up inside of a piece of concrete when it's first poured down. They'll use the vibrators just to get all those aggregates to settle down to the bottom before the curing starts. That way there's no movement, there's no cracking. It minimizes the chance of cracking, and it just makes the slab that much stronger when they vibrate it.
That's cool.
Yeah.
So and the reinforced steel, rebar, mesh, all that. I mean, that obviously will.
It's huge, and it's something that,
Is that, you come into that a lot? Is that
you come into a whole lot. And now we have ground penetrating radar, GPR, and that's made a huge difference in people being able to understand what kind of steel's in the structure that they're looking at, where before it was just basically trying to find old plans, talk to people, try to understand how much steel's in a certain structure. And it's extremely important. If you go on a bridge deck, say somewhere in Ohio, and you've got double mat of steel, and let's say it's on 12-inch centers, and let's say it's a number 5 bar. Real quick, when they categorize the sizes of bars, it's always 8. Number 8 bar is 8/8, so it's 1 inch. Number 4 bar is 4/8, so it's a 1/2 inch rebar. Number 12 rebar is 12/8, 1.5 rebar. So
I wonder why.
It's just, you need to know how big that rebar is, because like I say, if you had a single or double mat of steel in a bridge, it's number 4 bar and 12-inch centers. That's one application. But let's say there's a bridge right next to it that has 3 mats of steel, number 10 bar, and they're on 4-inch centers, which makes it much more concentrated. You're going to have completely different results on those two decks.
I'm sure.
Because of the amount of steel.
I wonder why, though. I wonder why when they came up with the rebar thing, they used the number 8 as their base.
That I don't know.
It's weird. Why not 10?
Yeah, exactly.
That's goofy.
But yeah, it's something good to know. And like anything else, the more you can learn about your structure before you get started cutting or drilling, the better off you are.
The more you know.
The more you know.
So we touched on this last time a little bit with green concrete.
It's not easy being
We
green.
can get more into it. Why would you cut green concrete? Why wouldn't you just wait for it to cure?
Well, because as we talked about the PSI strength, and we talked about how water is constantly evaporating from the slab. As the water evaporates, it's losing volume, obviously, so it's shrinking.
It shrinks?
Like a frightened turtle.
As it's shrinking, it's going to want to crack somewhere. It has to crack somewhere. So by weakening the planes, by cutting lines into the concrete, usually 1/4 inch of the thickness or 1/3 of the thickness, you control where that concrete's going to crack. And that's very important, because everything has to be laid out in a grid, because if you start getting sideways cracks that start going across the grid and it meets another crack, and then pretty soon you've got pop outs and everything else. So that's why you control the cracking. And also you're going to seal that piece of concrete to keep it waterproof. And that's also another reason you cut.
So we've got a line of products called First Cut. And so we have blades, saws, things to cut the green concrete. There's a control zone that we call it, and that's the optimal cutting time. Explain that.
Well, weather affects the green concrete process most than anything, I would say. You're looking at, if you pour concrete and it's 40 to 45 degrees when you pour that concrete, it may take 2 days before you can get a saw on that slab and cut it. Now, if you're in Phoenix or somewhere real warm and they pour the concrete, you may have to be on it in 4 hours versus 2 days. So the weather and how hot it is and how fast that concrete is the key to green sawing. The first cut method that we have was designed to be able to allow saws to get on slabs sooner to eliminate the possibility of unwanted cracks. Used to be before you'd have to wait till the slab was hard enough to put a bigger saw on it, and that ate up 3 or 4 hours of your control zone time. Now you can put it on a couple hours after the pour, and even if you don't do all your cuts, you can make enough relief cuts to at least eliminate cracking that could occur before you are able to get your full fleet on there and cut it properly.
So yeah, we've got a blade called Later, the Later blade.
Later, dudes.
If you miss that control zone, you can hit it, after the final set. Those have been working out, I hear.
Yeah, and then the idea behind that is we talk about, the harder the surface, the softer the blade you need, and the softer the surface, more abrasive, the harder the blade you need. The Later blade is as it cures and it starts getting to the point where it's no longer green and it starts to be cured. If you take a green blade, which is normally hard by nature, it's probably just going to chip that piece that's been exposed too long. The Later blade is a softer bond, which will allow you to cut it even after it starts entering the cured part of the control zone.
It's so weird. I mean, if you're not in that, you know what I mean? The difference between green concrete, cured concrete, the control zone in between, it's such an odd science, you know what I mean? But at least we've all come up with ways to calculate it, I guess.
Yes. And, a lot of people, you say green concrete to them.
They don't know what the hell you're talking about.
they think it's actually green.
Yeah, they do. I mean, if you weren't in the business, what
would you think?
First time I heard that, I had no idea what you guys were talking about. But then, like Jimmy, you were saying with that Later blade, I mean, there's not just green concrete and cured concrete. There's several subtle stages in between
that control zone that you mentioned. Correct.
Yeah, it's interesting that they've come up with a way to figure that out. I mentioned through trial and error and a lot of destroyed concrete slabs.
Yeah, there was a project, I'd say probably 35 years ago in Tupelo, Mississippi, and they had poured maybe 7/8 of a mile.
Is that where Elvis is from?
Thank you. Thank you very much.
And they poured it. The guys went out. They started cutting. And then they ran into a section that's too green. When you're cutting green concrete, you're kind of chasing the cured portion of it. And if you get into a section that's too green, it'll start to spall. Then you have to wait a little bit before you cut, let it cure up a little.
It reminds me of sort of walking on an icy pond, and there's some parts that aren't quite frozen all the way. Right.
So these two guys went out and they cut their first quarter of the job, and then they went back to their car and sat and had a few beers, and then they woke up the next morning to find probably half of that $1 million a mile slab was completely cracked randomly, had to be pulled out, tore out, and repoured.
Wow.
A lot of money. Needless to say, those guys were no longer working.
Well, not just to repour it, but to clear it out. There's a whole nother fee you didn't expect to have.
Exactly. Yeah.
Man alive. So how long did it take you to cut it all out and replace it?
Yeah, it took about a couple weeks just to get the mess cleaned up. Yeah.
What a mess.
So let's get into core bits. We didn't really talk about that. We've been talking about cutting with blades, but core bit. So what?
Well, core bits are probably a little more simple than diamond saw blades. They're probably a little more forgiving as well as a diamond tool as well. Not as many components. You've got the tube itself. You've got diamond segments that are welded onto the end of that diamond tube. And you leave little spaces in between those segments to allow the water to flow once you're cooling. And then on the top of the tube, you've got a built-in hub, whether it's 1 1/4" 7 or a 5/8 11 hub built into the tube itself. Now, at one time, we used to use open-end bits, and that's kind of a real archaic term these days. But it used to be the cost of the hub, the threaded adapter that you put in the back of the bit. They were pretty expensive. So people would order the bits without hubs on them. They would be open-ended, so they would get them. And there was an apparatus called a expanding adapter, which we still sell to this day, that can be put in the back of an open-end bit. And it works on a process of as the expansion adapter is screwed onto the core drill, it gets tighter inside that bit through pulling pressures. And that way you can change it. And it also makes it kind of nice because if you get core bits stuck, different things that could occur. If you could take that bit out, it gives you a lot more leeway to be able to try to figure out how to unstick it versus something that's got a hub on it. So, but very rarely do we sell them, but we still do sell them.
But don't we use those? They're called continental tubing, so you can continuously use them.
Yeah, and that is a different application. So continuous continental tubing is typically if you've got a very, very deep hole that you need to drill. There is a crown, which is a 12-inch long bit. That is also open-ended with threads, and there's a threaded cap that goes onto the back of that crown, we call it. They start by drilling that first 12-inch hole. They unscrew the threaded cap that's on the back of that bit. And then they'll take a barrel, which is female on one end, male on the other end. They'll screw it into the back of that bit, put the threaded cap on the barrel that they just screwed on, and continue drilling. And they can do that for typically, I've seen holes 120 feet deep with continental drilling. But typically 20, 30, 40 feet. You can't do that, obviously, with a regular core bit. So continental tubing is used.
So on the segments of the core bit, it basically acts like a diamond blade.
Exactly. Same kind of thing.
Yep.
And, we talk about the segments and, we've got, just like on the blades, we've got turbo designs on the segments as well. And we talk about turbos. We talk about segments that are waffle-like in appearance. And the reason for that is you're looking to reduce the drag, the resistance that comes when you're drilling with the bit. If you take out material, the less material that's touching that surface, the faster that bit will drill. But also, it'll also wear out faster. So we've got turbo style bits that are waffle type segments, and we've got conventional segments.
So there's sort of a give and take over speed of the cut versus the length that the bit's going to last.
Exactly.
And I kind of see where your budget is. Are you more concerned with one over the other?
You're correct. And once again, there's all kinds of factors that come in there. To some cutters, life is everything. They're in areas maybe where they're not paying their labor as much because of non-unions, and but in the east and the north, where unions are very common, you're paying a guy $60 an hour. You want nothing but speed.
I feel the need for speed.
You want him to go from job to job as fast as he can go.
Doesn't matter if you got to buy twice as many bits
because
you're saving money in the end.
You're saving your money on your labor.
So the RPM is a huge thing for core bits.
Yes, it is. It is. And, typically, your smaller diameters, your 7/8 1-inch bits can be like 3 to 3,500 RPM. And that's really fast, And, but that is the ideal and the optimum for those small bits, where if you're looking something along the lines of a big, 36-inch bit, you might be somewhere around 700 to 800 RPM. That just gives you an idea of the difference of the RPMs needed for different size bits.
So we have a lot of different configurations of segments and shapes and sizes, and there's a lot of different options that we can do.
It really comes down to speed, too. In most of the cases of the different configurations we offer, everything is either fast, faster, or fastest,
And we also have dry bits with a vacuum attachment, or you can just dry bits with a dry hole saw, as we call them.
Yes. And once again, those weren't around when I first started, and the dry hole saws and the dry drilling, but laser welding made that possible. So that's something.
I mean, were lasers even around when you started?
No.
Wait, what about cars and telephones?
Well, I had a crank telephone.
Oh,
Sarah,
man.
give me 619.
Sarah.
So we've got a
pilot.
So the water is also a big issue.
Well, yeah, water is huge, obviously, because I think we talked last time. We said you can cut with a dry tool, you can make it wet, but you can't make a wet tool dry. Basically, because a lot of times you have the wet blades, wet core bits, depending on the sizes that they are, but typically they'll be silver soldered versus laser welded. When it's silver soldered, that heat buildup that you get from the dry application will reheat those solder joints, and segments will start flying off. So once they had the availability of the They were able to laser weld the segments onto the bits. Now you've got the capability of drilling dry. But even still there's still a lot of caution has to be taken care of to make sure you don't, deform your bit with heat. It's got to be pulled out of the cut. It's got to be cooled down with maybe some air. Maybe you have a bucket of water on hand, dip it in the bucket of water, keep it cold.
When I dip, you dip, we dip.
But yeah, it's made a huge difference in our industry.
So in the winter, what do they do? If you're using water outside, how do you drill?
Antifreeze.
Okay.
Typically,
Really?
yeah.
That's
There's a lot of places,
just
obviously they're
shove
going
it
to try
in
to,
snow.
they're going to try to drill dry first, obviously. But if they're in an area where water is required, a lot of times they'll put antifreeze in their water. Obviously,
That's interesting. I guess that makes sense.
yes.
So, any interesting drilling jobs that you've seen?
Well, I do know a little story about a drilling job.
Tell us a little story.
I'll
Spin
tell you
us
a
a
little
yarn,
story.
Tom.
One day in 1983, I pulled up to Diamond Products, and I saw all these black vehicles sitting in front of the building.
Uh-oh. The feds?
Yeah, exactly. Yeah, how'd you know? Anyway, so I went walking up there, and I looked, and there's all these guys standing in suits in the office, and here it turns out there was a bank robbery in New York, and it was a successful bank robbery. And they figured out that the guy got in by taking an 18-inch core bit, going under the bank vault, take a Diamond Products core drill, and drill up through the bottom of the bank vault, get in and get out.
They don't secure the floor.
And that's what he did, but he left the bit and the drill rig behind. That's why we had a
came to
flood of
question us.
FBI officers coming to go through all of our records to see all the 18-inch bits we've sold in like the last 10 years.
catch 'em?
I don't believe they ever caught them.
No kidding. I love that you prefaced it by saying it was a successful bank robbery. It's like, yeah, no kidding, man. I never heard about that.
Yeah, and that was
We'll have to look it up and see if they ever caught the guy.
yeah.
So what do they do with metal? I mean, how do you drill through metal if he's going to get through a bank vault? And how do
But
Well,
it
that's
wasn't.
a
It was
good
just
one.
it was just a concrete
It
floor,
was
right?
it was a
Just concrete floor.
reinforced concrete slab, so the bit handled it. But now that you say that, we do have bits called plate cutter bits. Okay, and when you get into a situation where you've got solid steel, it could be a 3 or 4 inch plate. Obviously, a diamond core bit will not drill that. It would, but you'd have to keep resharpening the bit over and over and over again. It just would not be effective.
Yeah.
We have some bits we call carbide plate cutters, and they're basically look just like a core bit, but it fits on your core drill machine just like a core bit. But this is strictly for plate steel, and it's running a low RPM, and they work extremely well. And sometimes guys will get to these plates, they'll stop drilling, they'll get a plate cutter, they'll put it on, they'll go through the actual 3 or 4 inch plate, take that off, put their core drill bit back on, resume core drilling. A little tip for that, because we do sell a heck of a lot of carbide plate cutters. A little tip for that is when you're using those, the best thing you can do, you don't use water, you fill them with shaving cream.
Shaving cream, be nice and clean. Shave every day and you'll always look keen.
And that shaving cream acts as a self-lubricant as it goes down. So your bit's full of shaving cream, you put it up against the plate. As you're drilling, that shaving cream's leaking out and providing a lubricant, and it makes it a lot easier to drill. So,
Wow.
little tip there.
Yeah.
So any other factors for drilling that'll affect how it drills?
Okay, so really, I think in the 2 podcasts we've had here, we've talked a lot about aggregate, and now we've actually touched a lot on the steel itself. And those are probably the 2 most important components that you have to look at when you're getting ready to drill or saw. But I will say this, these are some of the factors that you got to really consider. All right, so we talked about aggregate, we talked about steel. Sand, that's another big one. And I will tell you, when you get onto a job and you want to know what kind of sand you have, it's either going to be one or 2 things. It's either going to be river sand or it's going to be pit sand. So river sand obviously comes out of the river. It's round. It's been in that water for a long time. It's lost all of its edges. It's super hard and it's super non-abrasive.
Is this in the concrete? The
Yes.
sand? Okay.
Yeah. So concrete's made up of aggregate. cement, sand, water.
Okay.
So the sand part, so if you put a river sand in there, it's very dull, non-abrasive. Now, a pit sand comes out of a pit where they extract aggregates, limestones, granites, whatever. The residual matter, they turn that into sand by pouncing it and breaking it to the point where it's the same gradation as
Just
sand.
ground up.
But now you're looking at a sand that has extremely sharp edges on it. There's been
Good
no
for us.
water. Exactly. So what that does is that increase the abrasion level of the concrete. So one way you can tell is if you walk onto a job, if you can find a piece of loose concrete somewhere, typically you can, a spall or something, a chip that comes off the patch. And if you hold it up to the sun and you look at it and you see glistening and you see facets, that's going to be a pit sand because you're looking at all those different angles and all those different squares. If you hold it up and it's dull, you see nothing, that's a river sand, round. And really that makes a huge performance factor, especially on very large jobs, grinding, grooving especially, but even on very large patch jobs. To know what kind of sand you're encountering is pretty important.
Because
Yes.
that coarse sand is going to keep our blades a bit sharper.
That is correct.
Right.
So that's probably one of the next biggest one. We talked about rebar, we talked about aggregate, and we talked about weather for green concrete, whether or not, how that affects your timing as far as your cutting and everything else. So those are just some of the factors that can affect your cutting performance.
That makes sense to me. How about you, James?
So when a blade or a bit stops cutting or drilling and you hear glazing, what is glazing?
Glazing is basically where you've when you first take your core bit out of or diamond blade out of the box, you can feel the edge of the segments that are around the bit or the blade, and you can feel the diamonds sticking up. You can even take a microscope or a magnifying glass and look, and you can actually see the points of the diamonds sticking out of the segment. Now, if for some reason you're using too much pressure, if the material is extremely hard, if you're not using enough water, a lot of times you'll knock off those points. So then what you end up with is a very, very smooth finish because there's no diamonds exposed, just flats and pop outs. So there you know that you've got a blade that just stopped cutting. So the next thing you got to do is think about how you're going to expose it again. And a lot of times we can do that by putting it in abrasive materials on the job, like an asphalt shoulder, into the dirt. Dirt is very abrasive. There's different ways you can sharpen a blade out in the field. And obviously at the Diamond Products, we get a lot of blades back for resharpening. We have big sharpening CNC type machines that do an excellent job. But when you're out in the field, there's certain things you can do to open that blade back up.
Cinder block?
Cinder block is something. Yeah, I mean, if you had like a real abrasive cinder block and you could cut into that a few times, that'd be good. And when you're core drilling, as long as it's a vertical hole, you can always get some alumina oxide 60 grit sand. Any hardware store sells it. And you may not, we sell sharpening pots that we put this sand into, and it's usually off to the side, and you can take your bit and you can sharpen it but if you're on a job and you're in the middle of a hole, you can also take that same alumina oxide sand, put it down in the hole,
Just pour it in the hole.
put a little bit of water in it, what you're trying to do is you're trying to trap those fines at the bottom of the hole, because you're trying to trap them and make them work to make that bit open up. So you do that for 2 or 3 minutes into that abrasive mixture. Your water's off at this point, but you've made like a sludge kind of down in your hole. 2 or 3 minutes sharpening it up, pull it out, take your water, eradicate all the sand, and you can go back to drilling. So
that's cool.
It's a good way to be able to. And a little bag of sand can be a core driller's best friend for sure.
So that usually happens when the aggregate's too hard. The segment heats up. It basically melts it in a way.
Correct.
Just soften the bond. Just get a softer bond if you had to, right?
And a good time to mention too. One of the ways we talk about sharpening bits, and when you're using a saw or a bit, and you have your water going to that tool. All right, you're flushing away all the fines and everything, which you're supposed to. But now let's say you get into a situation where you're starting to slow down and you don't have sand, you don't have anything really to sharpen it on. You can use your water control to actually make that bit cut a little faster or a little slower. So if your bit's cutting slow, if you turn your water back a little bit and you allow that slurry, which is the water mixed with the residual liquid coming out of the hole, you can basically create a abrasive enough mixture by cutting back your water that'll allow that bit to sharpen up to a certain degree and cut better. And because, but then, and the same, the opposite is true. If you've got a bit, you're looking at it in every hole, you're wearing off like 5 to 10 thousandths. You're thinking this bit's going to wear out, before I get 3 or 4 holes done. Yeah. At that point, you can increase your water, blow away all the fines, and then that way it's retarding the erosion of the segment itself.
Okay.
So our core bits, the brand is Core Bore. It's synonymous with drilling and core bits in the industry. Because people just think, give me a core bore. They don't say, give me a core bit. Because we've been doing it since 1964. So it's kind of very known as our bits are core bit, but it's core bore. So that's a little tidbit for everyone out there.
Nice.
So that's episode 2.
Yeah, man. Thanks again, Tom.
Oh, Pat, thanks for having me, guys.
Again, so this is our Diamond Products University podcast.
And you could hear this and listen to it on our website, on the training section of the website, and any of the platforms where you listen to podcasts.
All right, guys. Until next time, this is Jim.
This is Jim.
And this is Tom.
Thank you guys for listening.